All right, you guys, we're back for really part 3. I know this has been a lengthy lesson because it's a tedious process, like I said before. So if you're here with me to get this last exercise and to see it in a different way, that is great. Kudos to you guys. I very much appreciate that. Good for you for being here and taking the time to learn a little more and understand a little better. Okay, we're solving a 3x3 system here, but you'll notice I don't have the page of notes behind me. I have the template that I mentioned. Okay, and this template came from Mr. McGill, one of the other math teachers here. And it has shown to be very helpful for solving these systems. I'm sure many of you, at least some of you, will find this helpful as well. Okay, so this just helps to keep us organized, to help us focus on the process that we're performing. I'm sorry I don't have paper copies of these for you guys, but I do have it uploaded on our classroom page as a PDF. So if you have paper, I would recommend maybe setting up this template on your own paper so that you can use it, because it will likely benefit you. Okay? If not, though, again, it just gives a more clear idea of the process. And what I'm doing on here is exactly what I would be doing on the notes. It's just structured more clearly. Okay, so you can still follow along with me on your notes if you do not have a template set up for yourself. All right, so working with our original system, which I already have copied over here, I'm trying to color code it a little bit. We need to eliminate one variable. We need to use two sets of two different equations to eliminate that same variable to get it down to a 2x2 system. Right, we're trying to turn this into two equations with only two variables. So looking at this here, you want to figure out which variable does it look like would be easiest to eliminate by doing some manipulation. And there's no right answer here. You can choose whichever one you want, whichever you're more comfortable with. But make sure you have a reason. Don't just say, I'm going to do Z because Z is the last letter and no one likes it. Okay, that's not fair to Z. Make sure you think about it first, have a good reason and a good idea of why you're doing what you're doing. Okay? So for me, the x's jump out at me. 4x, 1x, and negative 2x. Those seem like they would be easier to manipulate to get to be opposites so we can eliminate one. So I'm going to eliminate x. That's the variable I'm focusing on. Okay? And the two that I'm going to start with, I'm going to start with 2 and equation 1 and 2, but I'm going to write equation 2 on top, and you'll see why in a minute. So I have x plus 5y minus 3z equals negative 37. Okay, that's equation 2. Now I said I'm also going to use equation 1. So I'm going to rewrite that now. I'm leaving a space between here. 4x minus 2y plus 3z equals 23. Okay? So now if I'm trying to eliminate x, that means I need the coefficients of x to be opposites of each other. So if I have a 4x here, I need this x to be negative 4x. And the only way we can get that is by multiplying this whole equation, the whole thing, every term inside there. I'm going to multiply everything there by negative 4. So that will give me then negative 4x minus 20y plus 12z equals, oh, this is a big number down here. I believe it's 148. But please, guys, make sure you're checking my work. Okay, I can make mistakes too. All right, and now we have these opposite coefficients for x, which means I can add the equations together using the addition property of equality to get another valid equation with only two variables. So negative 4x plus 4x, x is eliminated. That's what we wanted. Negative 20y minus 2y is negative 22y. 12z plus 3z is 15z. 148 plus 23 is 171. Whew. It's getting some big numbers here, bigger coefficients, a big constant on the end. That's okay, guys. Nothing we can't handle. Okay, so we eliminated x. We did what we needed to do there. Now moving down to step 3 here. Remember, we have to use 2 different equations, so not 1 and 2 again. We'll use 2 different equations to eliminate that same variable x. All right, now I'm going to use equations 2 and 3 now. Okay, equations 2 and 3. So again, I'm going to write equation 2 on top for the same reason I did over there, because I know that equation 2 is the one I'm going to be manipulating. So I have x plus 5y minus 3z equals negative 37. And my equation 3, I'll fill in underneath, again leaving a space, because I know I'm manipulating this one somehow. So I have negative 2x plus y plus 4z equals 27. Okay? So again, if we're eliminating the x's, we need those coefficients, the coefficient here and the coefficient here, to be opposites of each other. So if this one is negative 2x, that means this one needs to be positive 2x. So I'm going to multiply everything in this equation again by 2. So that gives me 2x plus 10y minus 6z equals negative 74. Okay, so far so good. Now we add these equations together because that's a legal, mathematically legal move. 2x minus 2x is 0. X eliminated. 10y plus y is 11y. Negative 6z plus 4z is minus 2z equals negative 74 plus 27 is negative 47. All right? So looking good so far. I hope it's looking good for you guys too. Okay? We now have 2 brand new equations with only a y and a z. The x's are gone. Okay? And now this box tells us to use the work from 2, or the work from this box, and the work from this box to solve for a variable. So I'm going to rewrite these here. So I have 11y minus 2z equals negative 47. And again, I'm leaving a space because I know I will need to manipulate one of these. So I rewrite this one down here. Negative 22y plus 15z equals 171. All right, so let's see. 11y, negative 22y, negative 2z, 15z. So I don't know about you guys, but it looks like right now that these y's would be easier to get to be opposites. If this is negative 22y, that means this will just need to be multiplied by 2 to give us 22y. So we multiply that. And again, each of these 3 terms in here has to be multiplied by 2. So I get 22y minus 4z equals negative 94. Now we can add those across this out just so kind of cut down the confusion here. We're working with these 2 equations now. Adding each column together, 22y minus 22y, boom, y is eliminated. And negative 4z plus 15z is 11z. That is equal to 77. 11z equals 77, which means if I divide both of these by 11, that gives me z equals 7. Bada bing, bada boom, we're 1/3 there. 1/3 of the way done. We have one solution. We have one value. We need the other 2 now. Okay? So let's see. Keep moving right along here, right through this process. Now it says use an equation from this box or this box to find the value of another variable. Okay? Since I have this equation right here, I'm going to use that one. 11y minus 2z equals negative 47. And I know that z equals 7 from my previous work. So I can substitute that in here. 11y minus 2 times 7 equals negative 47. All right, which means 11y minus 14 equals negative 47. If we add 14 to both sides, 11y equals negative 33. And look at that, just like we did there, we're dividing by 11. Just a coincidence, but coincidences are cool. So those are gone. Negative 33 divided by 11 means y equals negative 3. And bada bing, bada boom, we're 2/3 of the way done. Okay, we have our z value, we have our y value. The only thing left is that elusive x value. And we'll find that right over here. So we're going to use an original equation. Okay, an original equation, so we have to go all the way back to our first box here. We're going to use one of these to find that value of x. Okay, I'm going to use equation number 3, which is negative 2x plus y plus 4z equals 27. And since I know what y is equal to, and I know what z is equal to, I can substitute those values in their correct places and then solve for x. All right, I'm back. Don't know if you realized I took a break, but I had another class coming in, so I paused it. But now I'm back, and I did not end the recording, so I don't have to make another one. How great is that? Okay, so we're with our first original equation, negative 2x plus y plus 4z equals 27. And I'm at this stage. I'm now going to plug in my value for z that I found right up here and my value for y, which I found over here. So I'm going to rewrite, but filling in those values as I go. So negative 2x plus y, which is negative 3, plus 4z, which was 7. Yep. That's equal to 27. Okay. Now I get rid of these parentheses by just cleaning it up a little bit. Negative 2x minus 3 plus 28 equals 27. All right. Then we combine these two. That would give us 25. So I'll subtract 25 from both sides to get negative 2x equals 2. Now I'm down to a one-step equation, which we all love. Divide by negative 2, divide by negative 2. We get x equals negative 1. Bada bing, bada boom. 3 for 3. We just solved this linear system. 3 by 3 linear system, no less. So, guys, give it up for yourselves again. Way to stick it out. Way to be here with me. Okay? It takes a certain focus and determination to get through these, which I know we all possess, but it's a little harder sometimes to get it out, okay, and to exhibit it, right? All right? So the last thing I'm going to do here is I'm actually going to check my solutions. I just want to make sure that these are all correct. So I'm going to rewrite each of my originals, but as I rewrite them, I'm going to plug in the values. So I'm just going to remind myself here, x equals negative 1, y equals negative 3, z equals 7. Okay? So now my first equation is 4x minus 2y plus 3z equals 23. All right? So negative 4 plus 6 plus 21 equals 23. Negative 4 plus 6 is 2 plus 21. That is 23. So boom. That first equation works. Okay, each of those values, x, y, and z, satisfies this first equation. It makes this equation true. Okay? Next one. I have x, so negative 1, plus 5y minus 3z equals negative 37. All right, let's cross our fingers that this works out too, just like the first one. Negative 1 minus 15 minus 21 equals negative 37. Well, these are all negatives here. So negative 1 minus 15 is negative 16 minus 21. Bada bing, bada boom, negative 37. So that one checks out again. Our second equation is satisfied by all three of those values. And the last one, negative 2x plus y plus 4z equals 27. All right, last one, guys. Let's make this count. So this is 2 minus 3 plus 28 equals 27. 2 minus 3, that's negative 1. So negative 1 plus 28 is 100% 27. So again, that third equation is satisfied by those three values of x, y, and z. So 3 checks mean that these solutions, these values are correct. Okay? And that's it. That's what we got. So take some time to go through these videos again if you need to. Remind yourself of the process. Be ready for class on Monday. Thanks, guys.